ನಮಸ್ಕಾರ ಎಲ್ರಿಗೂ. Welcome back to Learning Management Systems, Department of Collegiate and Technical Education. Today I'm going to start with session 2 of transistors and MOSFETs. So in this session the following topics are covered: formation of transistors, working of transistors, both the types of transistors NPN and PNP, and the different ratings of transistor device. So as we have already discussed in the earlier session, a transistor consists of three layers, that is emitter, collector and base being the middle layer. So it can be thought as two PN junctions connected back to back as shown in the figure, but it is manufactured as a single piece of semiconductor device. So a transistor is nothing but two PN junctions connected back to back. So as we can see in this picture, in case of an NPN transistor, P-type layer is sandwiched between two N-type layers, and PNP transistor, in case of a PNP transistor, N layer is sandwiched between two P-type layers. For both the type of transistors, for external connection, three terminals are taken out. One is the collector, base and the emitter. So with respect to the formation of transistor, we can say that junction transistor is formed by sandwiching a thin layer of one type of semiconductor material, either N-type or P-type, between two layers of other type of semiconducting materials. Similarly, NPN transistor is formed by sandwiching a thin layer of P-type material between two layers of N-type materials. PNP transistor is formed sandwiching a thin layer of N-type material between two layers of P-type materials. Before getting into the working of NPN transistor, let us try to understand the transistor action. We all know that for the normal working operation, emitter base junction must be forward biased always. Similarly, the collector base junction must be reversed biased. Now let us assume that emitter base junction has no bias, that is emitter base junction is open. In that case, there will not be any emitter current and hence collector current is also zero. That is, if emitter current is zero, collector current is also zero. Of course, since your collector base junction is reverse biased, there will be very small amount of current flowing due to the minority charge carriers. But this current can be neglected in most of the practical situations. Now, if you introduce emitter base forward bias, there will be emitter current due to the forward biased signal, and hence you will have the collector current as well. That is, when emitter current is zero, your collector current will also be zero. If with the introduction of the emitter base bias, emitter current follows, similarly your collector current also flows in the circuit. This is one important feature that is used in the amplifier circuit. So with this, we can continue with the working NPN transistor. So as I said, emitter base junction is forward biased and the collector base junction is reverse biased. So due to the forward biased condition, electrons will be emitted, which are the majority charge carriers. In case of an NPN transistor, emitter emits the majority charge carrier electrons into the base. As the base is very lightly doped and it is very narrow, there are very few holes available for the combination. The remaining electrons will cross over to the collector junction. So the emitter emits the electrons. They enter the base region. So the flow of electrons in the emitter section give rise to the current, emitter current. These electrons, when get into the base region, as the base region is very narrow, only few electrons will combine with the holes. The remaining electrons will pass on to the collector. So when in the base region the electrons recombine with the holes, they become valence electrons. So you all know this concept. When an electron combines with the hole, they become valence electrons. And these valence electrons, they just move down towards the base terminal, constituting base current. The remaining electrons, they cross into the collector region and they flow in the collector region, constituting collector current. So in this picture, the direction arrow mark shown, it is for the electron movement. So please note this, the direction shown here, it is the electron current direction, but the conventional current direction is opposite to the electron flow direction. So let me come again. The electron emitter emits the majority charge carrier, which are electrons in case of an NPN transistor. So this constitutes the emitter current. These electrons, they get into the base region, they combine with the holes there, and the remaining electrons, they flow into the collector, constituting collector current. So the electrons, a few electrons which combine with the holes in the base region, it constitutes the base current. Why most of the electrons emitted by the emitter enter into the collector? There are two reasons for this. As we all know, the base region is very thin and it is very lightly doped. Hence, we have only few holes available for the recombination with the electrons. The second reason being, your collector base junction is quite strongly reverse biased. So this reverse bias voltage will attract the electrons emitted by the emitter towards the collector. Hence, most of the electrons, they cross over to the collector junction. Hence, we can say that the total current that is emitted by the emitter is equal to the base current plus collector current. So that's all. That's what we have in the slide. It is just the summarization of what I have explained just now. So NPN, the figure, it was showing NPN transistor with emitter base junction forward biased and collector base junction reverse biased. The forward bias on the EB junction, it causes the electrons in the N-type to flow towards the base, and this constitutes the emitter current, IE. And as base is very lightly doped, only few electrons, maybe less than 5%, combine with the holes, constituting the base current, IB. The remaining electrons, more than 95%, they cross over into the collector region to constitute collector current, IC. So we can say that almost entire emitter current flows in the collector circuit. Hence, we have this expression for the NPN transistor, IE is equal to IB plus IC. In the similar manner, we can understand the working of PNP transistor. In a PNP transistor, we have N-type base region sandwiched between two P-type regions. As always, emitter base junction is forward biased and collector base junction is reverse biased. You can notice that in the figure, the positive terminal of VEB, that is emitter base junction bias VEB, the positive terminal of the battery, it is connected to the emitter terminal, that is P-type terminal. Similarly, VCB, the reverse biased VCB, the negative terminal is connected to the P-type material collector. So your EB junction is forward biased, whereas collector base junction is reverse biased. So the forward biased in the emitter base junction causes the majority charge carriers because your emitter is P-type material. Hence, in case of a P-type material, holes are the majority charge carriers. The holes are injected by the emitter and they flow towards the base terminal. So this constitute the current, emitter current IE. So these holes emitted by the emitter, they cross into the N-type base. So in base, electrons are the majority charge carrier. As it is very narrow and lightly doped, there are only few electrons available for the holes to recombine, that is less than 5%, and they flow as the base current, that constituting IB. The remaining holes, they cross over to the collector junction and forming the collector current IC. In this case also, the total current IE is equal to IB plus IC. So very important point to be noted that in case of a PNP transistor, within the transistor, the current conduction is due to holes and electrons. We know that. But in the external wire, external connection, the current is due to only electrons. So this is very important point to be noted in case of a PNP transistor. So the same thing has been written here. It must be noted that current conduction within PNP transistor is by hole. However, in the external connecting wires, the current is by electrons only. So now let's get on to the ratings of the transistor. Like any other electrical or electronic devices, even the transistors are rated for the voltage, current and power components. So the first rating is the power dissipation. As we all know, it is nothing but the maximum allowable power that can be handled by a transistor without being destroyed. See, collector is the region which is collecting the majority charge carriers, and during the transfer of current during the flow of current from emitter to the collector, so there is a voltage drop between the emitter and the collector. So this product of collector current and the collector emitter voltage is nothing but the power dissipation. So without being damaged, what's the maximum power a transistor can handle is nothing but the power dissipation. The next rating in case of a transistor is reverse voltages. So reverse voltage is the maximum voltage, maximum reverse voltage that can be allowed for the junctions, that is collector base junction, emitter base junction, and also between the collector and emitter terminals. Collector current. So this maximum allowable collector current is specified by the manufacturer himself. So this is the current that can be handled by a transistor safely, because as the collector current increases, temperature increases. As the temperature increases, power dissipation also increases. So if the collector current is beyond the maximum allowable collector current, your transistor may get damaged. So collector current is the maximum allowable collector current that can be flown in a transistor without being damaged. Next rating is the beta value. Beta is nothing but the collector current divided by the base current. This beta and alpha we are going to discuss in the next sessions. So as of now, beta is nothing but collector current divided by the base current, and alpha is the collector current divided by the emitter current. So in case of beta, as the base current is very less, because it is very lightly doped, so the beta value is quite large for a transistor. So it ranges between 20 to 500. The beta value ranges between 20 to 500. In alpha, since emitter current and collector current, they are almost same, so alpha value is very less. It is in the range of 0.9 to 0.99. It is always less than unity. So these are the 5 important transistor ratings that we have to look into. First one is the power dissipation, reverse voltages, collector current, which is the maximum allowable collector current, beta value and the alpha value. So let me summarize through the session. So in this session, we have learned about the concept of formation of transistor. So how a transistor is formed, it is very simple. In case of an NPN transistor, how an NPN transistor is formed? By sandwiching a p-type layer between two n-type layers, and the PNP transistor is formed by sandwiching n-type semiconducting material between two p-type layers. And we have discussed on the working situation, working condition of the transistor as well. In both the case of transistor, it should be noted that the total current, that is IE, is equal to the base current and the collector current. And we have also understood the concept of ratings of transistor as well. So let me take you through a few multi-choice questions related to this session. So the first question is for normal operation of a PNP transistor, the base must be dash with respect to the emitter and dash with respect to the collector. It is related to the biasing. Okay, ಹೇಗೆ ನಾವು PNP ಟ್ರಾನ್ಸಿಸ್ಟರ್ನ ಬಯಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂತ ಸಂದರ್ಭದಲ್ಲಿ ಬೇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಮಿಟರ್ ಮತ್ತೆ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಕಲೆಕ್ಟರ್ ಯಾವ ತರ ಕನೆಕ್ಟಿವಿಟಿ ಇರಬೇಕು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ. ಸೊ ಯು ನೋ ದಟ್ for be it any transistor PNP or NPN, we know that emitter base junction must be forward biased and collector base junction must be reverse biased. ಹಾಗಿದ್ದಾಗ PNP transistor ನಲ್ಲಿ base with respect to the emitter ಏನಾಗಿರಬೇಕು? ನೆಗೆಟಿವ್ ಆಗಿರಬೇಕು. ಅದೇ ತರ with respect to the collector it must be positive. So the option is C. So we have four options: positive, negative, positive, positive, negative, positive, and negative, negative. So third option, that is option C, is the right answer. So this is the second question. Which of the following is true for an NPN or PNP transistor? Okay, let us go through the options available. IE is equal to IB plus IC. IB is equal to IC plus IE. IC is equal to IB plus IE. And the fourth option is none of the above. So which is the right answer? In both the cases, IE is equal to IB plus IC. That is, emitter current is the summation of base current and the collector current. So option A is the right answer. Next question is, a transistor is a dash operated device. A transistor is a dash operated device. We know that emitter inject majority charge carriers into the base, and base controls the flow of these majority charge carriers. That is, it controls the flow of current from emitter to collector. Hence, it is a current operated device. So let us consider the options. Option A is current, B is voltage, C is both current and voltage, and D is none of the above. So option A, current, is the right answer. A transistor is a current operated device. Next question is, which of the following is valid for both PNP as well as NPN transistor? The emitter inject holes into the base region. The electrons are the minority carriers in the base region. The emitter base junction is forward biased for active operation. When biased in the active region, collector current flows into emitter terminal. So the question, let me repeat the question. Which of the following is valid for both PNP and NPN transistor? ಎರಡೂ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ಗೂ ವ್ಯಾಲಿಡ್ ಆಗ್ತಾ ಇರುವಂತಹ ಸ್ಟೇಟ್ಮೆಂಟ್ ಯಾವುದು ಅಂತ. The emitter inject holes into the base region. This is a wrong option because in case of a PNP transistor, it injects holes, but in case of an NPN transistor, the emitter injects electrons. So the first option is wrong. The electrons are the minority carriers in the base region. This is also wrong option because PNP transistor nalli electrons majority charge carriers in base region, whereas holes are the minority charge carriers in base region. NPN transistor adre holes are the majority charge carriers in the base region and electrons are the minority charge carriers in base region. So hagagi ee option kuda tappu. The EB junction is forward biased for active region. Yes, this is the right option because whether it is a PNP transistor or an NPN transistor, emitter base junction must always be forward biased for active operation of the transistor. But still, let us look into the fourth option. When biased in the active region, current flows into the emitter terminal. The direction of emitter current changes with respect to the PNP and NPN transistor. In case of a PNP transistor, the current flow is towards the base, that is towards the transistor. In case of an NPN transistor, the current flow is away from the transistor. Hence, option C is the right answer. Let us go through the fifth question. Majority carriers emitted by the emitter, let's look into the options. Mostly recombine in base region, mostly pass through the base region, are stopped by the collector junction barrier, recombine in the collector region. So we know that majority charge carriers emitted by the emitter, it is most of the charge carriers, they are passed on to the collector. Okay, as the base is very lightly doped, only few carriers are available for recombination. The rest of the majority charge carriers are passed on to the collector region. ಹಾಗಿದ್ದಾಗ ಯಾವ option right answer ಆಗಿದೆ? So option B, mostly pass through the base region. ಎಲ್ಲ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಎಮಿಟರ್ ಇಂದ ಎಮಿಟ್ ಆಗಿರುವಂತಹ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಅದರಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ ಅರೌಂಡ್ more than 95%. We have seen that. We have gone through that. So above more than 95% of the majority charge carriers are passed on to the base region. Hence option B is the right answer. So that's all we have for the today in this session 2, transistors and MOSFETs of analog electronics. Thank you.